Welcome to day 15 of the Advent of Code. Today is about a numbers game where players take turns saying one number each. Let me explain the rules with an example. So we start with the numbers 0, 3, 6. Those are the starting numbers. And here you can already see my choice of implementation. I say for each number I have to remember at which turn in the game it was spoken last. And we start with 1. So 0 was spoken at turn 1, 3 at 2, and 6 at 3. Okay, and then since the last number spoken is a new number, we hadn't seen it before, by definition the next number is 0 at turn 4. Okay, and these turns simply always increment by 1. Okay, so this means we have to replace the mapping 0, 1 with 0, 4. And the difference between those values is 3. That's why the next number is 3 at turn 5. Okay, so we have to replace 3, 2 with 3, 5. The difference is 3 again, so we chose 3 again for turn 6. So we have to replace 3, 5 with 3, 6. Okay, the difference here is 1, so the next number is 1 at turn 7. 1 is a new number, so we insert it into the map and chose 0 for the next number. And so on. Those are the basic rules. Okay, so the parsing of the input, these comma-separated values I already implemented. Here you can see the example input with the example output. So I want to have a sequence of those pairs. Okay, and the interesting part here is the map indexed function, which not only passes the current item into the function that we provide, but also an index, right? So we don't have to create an infinite range and then interleave that with our collection and then partition and then map over the pairs. This is a lot simpler. Map index was mentioned by a viewer on a previous video. Thank you very much for that tip. Okay, and here I have to increment the index because I want to start at 1 instead of 0. And of course the number has to be passed from string to int. Okay, so maybe let's start by simply calling that function. Let's say starting small. Then we get the sequence as in the comment here above. And how would we now turn this into the map? Maybe you already know there's the good old intro function starting with an empty map, and then we get that map. That's looking good. Okay, so let's use a loop binding and say we call that spoken because those are the numbers that were spoken in the past. The next number is going to be 0 because in part 1 and part 2 there are no duplicate numbers here. So the next number is always 0. And the turn is 1 more than the count of spoken, right? If there are 3 elements inside spoken, then count should be 4. Okay. And maybe let's comment that for the next maintainer. So for our concrete example, this would be that map. Number would be 0 and turn would be 4. Okay, so first maybe let's check if we have reached the end. The end in our case is for now at turn 10. Let's do it like this. If we have reached the end, we can simply return the number. Okay, otherwise we want to recur. And now we have to provide new bindings for spoken, number, and turn, and I like to do that on separate lines. That's just my personal style. Okay, so how does spoken get updated? We want to associate spoken and then a key value pair. So the number now occurs at that turn. And the new number is, how did we compute it? We computed the difference between the current turn and the previous entry. For example, here with 6, 5, or for example, here with 5, 2, right? We have to simply subtract. So the current turn minus the old entry for the spoken number. And you might think, wait a minute, you are looking inside the spoken map at the number key, but didn't you just replace that mapping with a new value? And the answer is no, because assoc doesn't change the map. It gives you back a new map. The original map is unchanged. That's one of the benefits of persistent collections. You can't screw yourself up like this. Okay, and the turn simply increments, right? And then we should get an interesting error. Here we have a null pointer exception. because we didn't account for the case when there's a new number, like here or like here. Right? If there's a new number, this means we won't find an entry for that number, so we get null, and you can't subtract null from turn. Null is not the same as 0. Okay. So we could, look at the map and ask it, do you have an entry? And if not, I'm going to use 0, otherwise I'm going to subtract. But we can use a silly little trick. So if we want this complete expression to be 0 if there is no mapping in the map, then we can use the get function, which is usually not necessary. So get spoken number is exactly the same as just spoken number, because numbers are maps of their keys. But get has a second arity that takes a not found value, which is returned if the key is not found. So if here we simply return turn for the not found, then we will calculate turn minus turn, and that of course is 0. And then we get a non-exciting result of 0, but that is correct at turn 10. Let's check the next value was 2020. Yeah, then we get 436. That is correct. And for the large collection, that was 700 something. Yeah, 763. That's also correct. And now let us time this, because I want to change now from 2020 to 30. 1, 2, 3, 4, 5, 6. 30 million. Okay. Let's see how long this now takes. Before I recorded, I tested this, and it took about 12 seconds. So quite a long time, but still okay. With the recording software in the background, it's usually somewhat slower. Yeah, there we go, 16 seconds. Okay, so with a better choice of data structure, we could probably make this a bit more efficient. For example, here we use a persistent map, and the assoc function provides a new version, which has some overhead. But since we're not really interested in the old value apart from this line, if we could swap those two lines, let me simply swap them. And then, of course, I also have to swap the according lines here in the loop. Then I can say at this point, I'm not really interested in the old value anymore. So why don't we use a transient version of that map instead of a persistent one? Transient versions are usually faster for lots of updates. Okay, then we get another exception, I think. Yeah, that's because the assoc function only works for persistent collections, and if we want to use it for, or if we want to assoc on transients, we have to use the version with an exclamation mark at the end. And let's see how long this goes. So the exclamation mark at the end is a naming convention that says, hey, I'm going to change something here. Here's a side effect. Be aware of that. Whereas other functions don't have that. Yeah, and now we have about 12 or 13 milliseconds. Last time I had 12. Okay, so 12 instead of 16, so that's about 25% faster, right? That's not drastic, but better than nothing. Okay, so let me know how you solved this puzzle, especially which data structure you chose. I think with native Java collections, this could be sped up even more, or maybe you have an even better idea to speed this up. Let me know in the comment section below.